So last time I stopped up to increasing and decreasing function, and I said I give the definition: f is increasing on an interval I if f of x1 is less than f of x2 whenever x1 is less than x2 in the interval. Same things for decreasing. The function is decreasing on an interval if I have interval if f of x1 is greater than f of x2 whenever x1 is less than x2 in interval. Let me explain what does that mean. So in the picture here, the function here is increasing. Why? Look, x1 is less than x2. The value for this one is less than for the value of x2. And similar, f of x1 is less than for f of x2. This means the function in this interval from x1 to x2 is increasing. Look to the picture 2 here. x1 is less than x2, but f of x1 is greater than f of x2. This means, by using the definition here, the function is decreasing. But in general, if you want to know the function is increasing or decreasing, just look into the function, go from left side to the right side. If the function is increasing from left to the right, look, the value is increasing. I mean increasing, the y value is increasing. You go from the left side here to the right side here, and you see the function is increasing. I mean the y values are increasing. This means the function is increasing. Same things, if you go from the left side to the right side and you see the value for the function is decreasing, this means the function is decreasing. Okay, so again he said x1 is greater than x2 on the interval, close interval I, x1 comma x1 comma x2, and same time f of x1 is greater than of f of x2 on the same interval for x. So this is mean the function f is increasing. Here, x1 is greater than x2, but on the interval I can choose any interval from 0. Here I can choose any interval. It's not supposed to be from x1 to x2. I can set here the interval I, any interval I. On I could be from 0 to infinity, or any interval that containing this 2 points, x1 and x2. So here x1 and is greater than x2 on the interval I, but look, x1, f of x1 is smaller than f of x2. This means the function, I'm going to give this function name as g. The function g is decreasing. Any question for these things, for the definition? Is it clear, the definition? How to find the decreasing and increasing function? Okay. Example. Uh, Find in which f is hold on. Find in which f is increasing or decreasing in the graph. So I have a graph here, and the graph is like this. This point is A, B, C, D, F, G, H, I, J. And this is a function f of x. This is x-axis. This is y-axis. Which interval the function is decreasing or increasing? Where is the function here is increasing and where is decreasing?
From A to C, it's increasing. From C to F, it's
Hold on.
decreasing.
From A to C is
It's
decreasing.
increasing.
But look, the function is goes up and goes down.
Oh, okay, so decreasing, I guess.
Decrease. What about is increasing here until here, then decreasing until here?
Well, so A to B is increasing. Then
Okay.
B to C is decreasing.
Okay, perfect. Nice. This is nice. But I can say, what about this element here? Like, because the function is come from minus infinity here.
From minus
So
infinity to A is also increasing.
yes, so from minus infinity to A is increasing, and from A to B is increasing too, right? Like he said.
Right, so from minus infinity to B, it's increasing.
Nice. Perfect. This is what I said, what I need. So from minus infinity to B up to this point, from everything here from down up to this point is increasing. The function is increasing. Then from this point goes down up to this point, the function is decreasing. Then the function is increasing again. From this point goes up to here, this point. Then the function decreasing again until here, then increasing forever. Okay? So I can set the function f of x is increasing on the interval first interval from minus infinity, from this here, until this point, B. Why? Because until this point, from minus infinity, from all this point until this point here is increasing, the function increasing. So from minus infinity to the point B is increasing, goes up, function here goes up. Then the function goes down here up to this point here, and this point is D. So also, so the function is increasing on the interval from minus infinity to B, then increasing again from this point D to G. This point, from this point is D to G, and also from D comma G is increasing. It goes up. Then the function goes down here until this point, then it goes up again from this point to infinity, and increasing from the point I to infinity. Here closed interval or open interval. In general, we make it open interval. Okay. So the function is increasing on these intervals, and the function f of x is decreasing on the interval from this point until this point is D, from B to D, from B comma D, and also is decreasing from this point here G to I, and G comma I. And what else? That's it. So it has one interval, and the second interval is this one. Any question? Make sense? Okay. If there is no questions, let's go to the local minimum and maximum value. Local maximum and minimum values of a function. So now, if I give you a graph, I'm going to use the same graph from before, or I'm going to do another one. Suppose the graph of the function look like this. This is f of x. So the point where the function is changed from increasing to decreasing, this point here, is called local maximum. From increasing to decreasing is called local maximum. And changing from decreasing to increasing, this point is called local minimum. Same things here, local maximum, because it's changed the function from increasing to decreasing. And again, from decreasing to increasing, local minimum. So I can say this point here is local maximum. And this point is local maximum. And this point here, local minimum. And the same things here, local minimum. This is local maximum, but here I give you also, suppose this point again, A, B, C, D, D, E, F, G, H, I. So here, this point is local maximum, and its value at x equal b, and its value is f of b. Same things here. This point is local maximum at the point here at x equal f, and its value is f of f. F of f, this is here the point, f here is the function. F here is the function, f is the point, f, small f. Let's make the function capital F, because I don't want to let you confused. So suppose my function is capital F. My function here is capital F, not the small f. F capital of x. So here the value is f capital of the small b, here f capital of the small f. Okay. Same things here for local minimum. Local minimum at x equal h, and its value f capital of h. Here the same things at x equal d, and this value at capital of d. Okay, any question? How to find the local maximum and local minimum? Okay, let's go back to the same example here. So the function has local maximum at x equal b and at x equal g, that's it. And the function has local minimum at x equal d, this point, at this point, and at x equal I. This is local minimum, local minimum, local maximum, local maximum. The function is increasing at this interval, and at this interval, and this interval, decreasing from this interval, from this point to this point, and from this point to this point. in this interval and this interval. Okay.
Oh, that guy went in there. Okay, so we're gonna go in there. Okay, guys, I'm not gonna show you what the exit. I'm not gonna show you what happened.
Any question?
Part. What happened was, show yourself. You know you've been watching us.
Stephen,
And here it is, guys. George.
you turn on the mic. Do you have a question?
Oh, sorry, that was an accident.
No problem. Anyone has a question? So we finished this section, this section. Now let's go to the 2.4. 2.4. Average rate of change. Of a function. So before I start this section, anyone has a question from previous sections, or if you have any, like something you cannot understand it, you can do it together before I start this section, because I don't want to let you lose for this course. I mean, if you're following the web sign and you have like question you cannot understand, we can do it right now together. Or if you have anything, you can email me. We can like do a Zoom meeting, can help you before the exam to starting. So in this section, I'm going to give you two formula only. The first formula is the net change of the function. Second formula is the average rate of the change. And these two formulas, we're going to use it for all examples during this section. The first formula here is the net change of a function f of x between x equal a and x equal b is given as f of b minus f of a. This is the first formula you have to know for the net change. Second formula is the average rate of change. The average of the function I mean the function of this function f of x, that change between x equal a to x equal b, is average rate of change equal the net change over b minus a, or in the other word is f of b, because the net change is given in the formula above, f of b minus f of a over b minus a. Okay, so let me give you example. So the example now. Oh, by the way, this is f of b minus f of a over b minus a. It's look like a slope. This is look like a slope, but this is not the slope for any curve. This is the slope of the secant line. If I have a secant line between the point on the graph, it's going to be like look like the slope of the secant line. But if the graph, for example, is a line, linear, for example, function f of x equal ax plus b, like 5x plus 3, for example, this function is linear, okay? So the average rate of change is going to be like the slope of this function, because the graph for this function, something like that, okay? So the average rate of change, it's look like the slope of this function. But if the function, for example, is not linear, something like that, and the question is find the average rate of change between this point and this point, it's going to be like the secant line. If I have secant line, this is my secant line. The secant line has this formula. The slope of the secant line has this formula. So the example now, let the function f of x equal 3x minus 5. Find the average rate of change between number 1, x equals 0, comma, x equal 1, uh, b x equal 3, and x equal, for example, 7. Who will do the first one? The average rate of change between this 2 point and this 2 point.
So it's 1 minus 0
Yes,
over
okay, average rate of change equal 1 minus f of 1, right?
yeah,
f1 minus f of 0
yeah,
over what?
over
b minus a,
1 minus 0.
1 minus 0. So Mobin, she said, this is my a, this is my b. This point is b, this point is a. Now I plug inside the formula. F of b is f of 1 minus f of a is f of 0 over b minus a. b is again 1 minus 0. Now f of 1 I plug inside the function. Plug the 1 inside this function. F of 1 is 3 times 1 minus 5. Minus f of 0, I plug it inside this function again, 3 times 0 minus 5. And 1 minus 0 is 1. And everything over 1 gonna be like the numerator only. But I'm going to put it here over 1. This is equal 3 times 1 is 3, minus 5 is minus 2, minus 3 times 0 is 0, minus 5 is minus 5, over 1, we don't need the 1, equal minus 2 minus minus 5, minus minus 5 is positive 5, so minus 2 plus 5 is 3. So the average rate of change for the first point is 3. This is A. Now for B, average rate of change again is f of 7 minus f of 3 over 7 minus 3. First, here again, this is B and this is A. You plug inside this formula, f of B is f of 7 minus f of A is f of 3 over 7 minus 3. The function is 3x minus 5. So you plug the 7 inside the 3x minus 5 and get 3 times 7 minus 5 minus this one, 3 times 3 minus 5 over 7 minus 3 is 4. 7 times 3 is 21 minus 5 is 16 minus 3 times 3 is 9 minus 5 is 4 over 4. 16 minus 4 is 12 over 4, and the final answer is 3. So the first one, the average rate of change here is 3. For the second one, the average rate of change again 3. Why they are similar? Why this equal the same things for the second one? Because the function is linear. If the function is linear, the average rate of change always the same between any 2 points. Okay? If I put here any 2 points from 0 to 1, 3, 5, 5, 7, 6, 20, the average rate of change is going to be the same, 3. Always give me 3. Why? Because the function here is linear. 3x minus 5 is a linear function. Linear function mean the exponent for the variable is 1, because the exponent for the variable x is 1. That's mean the function is linear. So here I can say the linear have constant rate of change. So any linear function, always the rate of change are constant, the same for all values. Okay. I give another example. Example 1. Example 2. Find the average rate of change for the function f of x equal x minus 3 square between the point x equal 1 and x equal 3, b x equal 4 and x equal 7. Who will do the first one? By using the formula. Again, the formula is average rate of change equal f of b minus f of a over b minus a. This called the net of change. This only here is the net of change. Okay, I give you like 2 minutes to do the first one and the second one, then I'm going to solve them. Okay, who will do the first one? X equal 1 and x equal 3.
It's f plus f3 minus f1
Over.
over 3 minus 1.
Okay, nice. So the first one, average rate of change equal f3 minus f of 1 over 3 minus 1. What is f of 3?
3 minus 3 square.
Square. Minus
1 minus 3 square.
3 square. Over 3 minus 1,
2.
2. Now 3 minus 3 square is 0, square is 0. Minus what? 1 minus 3 is
Negative 2.
negative 2 square,
And then 4.
negative 4 over 2. The answer is negative 2. So the average rate of change for the first one is negative 2. For the second one, average rate of change. Who will do the second one? Juwan, would you like to do it? The second one is between 4 and 7 for this function.
F7,
Of what here?
7
7,
minus F4
4 over what?
over 7 minus 4.
7 minus 4 is 3, right? Oh, hold
Yeah.
on. 3, okay. Now you plug the 7 inside the function. The function is x minus 3, the function here. So x7 minus 3 square minus 4 minus 3 square. 7 minus 4 is 3. This is equal 7 minus 3 is 4 square 16 and 4 minus 3 is 1 square is 1 over 3. 16 minus 1 is 15 over 3 and the answer is 5. Thank you. So look, the average rate of change between this point and this point are different. It's minus 2 and 5. The average rate for the first one is minus 2. The average rate of between 7 and 4 is 5. Is not the same. Is not the same. Why? Because the function f of x equal x minus 3 square is not linear. Is not linear function. Because it's not linear function, so this is mean the average rate of change is not the same for any between any 2 points. So the average rate of change is not a constant between any 2 points. You have, if both answers same means linear, you have to check it in general. Does not mean like if there's 2 points are, you have to check 3. If 3 and more are the same, this means the function is linear. If you check the average rate of change between like at least between at least 3, like 3 times, and all of them the same, this is mean linear. Because maybe suddenly for the average rate of change between the first 2 points and the second 2 points are giving me the same number, but for the third one, they're not giving me the same number. So if the third one doesn't give me the same average rate of change, this means the function is not linear. Okay. That's it for this here. We finished this section. Just you have to know the average rate of change. Oh. Okay. Now let's go to the new section, 2.5. Is linear function and models. So first of all, we have to know what is the mean of linear function. So linear function. So we learned before the linear equation. Now we're going to learn the linear function. So the linear function is a function of the form, is a function of the form f of x equal ax plus b. If I see any function of this form, this means the function is linear. X here is the variable. A is called the coefficient, the leading coefficient. B here, or it's the slope. B here is the y-intercept. So let me specify. A here is the slope, and this is the y-intercept. So the graph for this function here, the graph is going to be like a line. So the graph of the function f of x is a line. This line has a slope a with a slope a. This is the slope, and y-intercept is b, and y-intercept b. Okay. Now let me give you example. Determine which of the following is a linear function or not. So example, the question is determine of the following is linear function or not. First one is f of x equal 2 plus 3x. B here, g of x equal 3 times 1 minus 2x. C, h of x equal x times 4 minus or plus 3x. And D is h of x, g of x equal 1 minus 5x over 4. For the first one, determine of the following if this is a linear or not. Is the first one of x equal 2 plus 3x is a linear? Is it equivalent to something like that?
Yes.
Yes. So the first one is a linear. Why? Because if we look into the form of the linear is f of x equal a times x plus b. So this is actually equal, if I want to make it the same as this one, is equal to 3x plus 2. Since 3 is slope, and this is equal to a, this is a, and this is the y-intercept, the b. So this function is a linear. Yes, it is linear function. It's clear? Okay, this is A, and this is B. Okay, second one. So the linear f of x, again, is equal ax plus b. Any function equivalent to this one is linear. Now this one, is it a linear? G of x is a linear?
Yes.
Yes, exactly. Why? Because if I wanna expand this one, distribute the 3 inside the parentheses, I get 3 times 1 is 3, minus 3 times 2 is 6x. And again, this is equal minus 6x plus 3. So minus 6 is my A, and 3 is my B here. This is A, the slope, and this is the y-intercept. This means it is yes, it is linear function. Who will do the third one? C.
S at 4x plus 3x squared.
This is equal 4x. We distribute the x inside the parentheses, 4x plus 3x squared. And here we have exponent of the variable, this one is 2. Because the exponent is 2, this means the function is not linear. To be linear, it must be the exponent for the variable is 1. Because we have 2 here, let's make the function not linear. So the answer is no, because the exponent of 3x squared is 2. And 2, let's make the function not linear. For the last one, Yes, yeah, that's true. Why? Because again, I want to make this one equivalent to this one, to this original function. It's gonna be like something like that. We distribute the 4, give me 1 over 4 minus 5 over 4 x. Now this is equal minus 5 over 4 x plus 1 over 4. Again, this is my A, this is my B. This is the slope. This is the y-intercept. So yes, it is a linear. Any question? Is it clear how to check this function is linear or not? Okay, example 2. Graph a linear function. So the question is, let f be a linear function f of x equal 3x plus 2. First question here, make a table of values and sketch a graph. Second question is, find the slope from the values on the table. Okay, make a table of values. Let me make a table here. I'm going to graph the function here on this side of the paper. And here is the table. Now let's take a values. For example, let's take here x and here f of x. Let's take positive, negative numbers, whatever, or 0. So let's take 0, 1, 2, 3, and here we take the negative numbers -1 and -2. What is the value for 0? What is f of 0 after you plug it inside the function?
2.
It's 2. Yep. What about 1? To plug the 1 here, I get 5. Thanks. For the 2, 3 times 2 is 6 plus 8. And for 3 is 3 times 3, 9, 11. What about the minus? Minus 1. 3 times minus 1 is
-1.
negative 1, yes. Negative 2.
It's -4.
Negative 4. Okay, now we plug this point inside the Cartesian plane. At 0, this is the point 0, is 2. 2, 5. So here is like 1, 2, 3, 4, 5, 6, 7. At 0 is 2. Here is the 2. At 1 is 5. This is 1. Going to be 1, 2, 3, 4, 5. Like around here. This is 1. This is 0. At 2 is 8. Here is 2. Like around here. Then we draw a line between these points. The same things for negatives. At -1 is -1, so this is -1. At -1 is -1, like around here. It's not accurate, but if you do it in the graph calculator, you will see this is -1 here. At -2 is -4, the same things for -2, down, like around here. But this is the line graph for this function, f of x equal 3x plus 2. This is 1, 2, 3, 4, 5, 6, 7. It's clear how to graph the linear function. This is x-axis, this is y-axis. So this is the first part. Second part. Find the slope from the values on the table. From the table here, I'm going to find the slope. How can I find the slope? What is the formula? Give me the formula for the slope.
M equals y2 minus y1 over x2 minus x1.
Thank you. That's true. So the formula is y2 minus 1 over x2 minus x1. So here I'm going to choose, for example, this point, and I'm going to use this point. This point here is 0, x1 equals 0, and y1 equal 2, and here x1 equal 2, and x2 equal 2, y2 equal 8. Plug inside this one the formula y2 minus y1, 8 minus 2 over x2 is 2 minus x1 is 0, 2 minus 0. I get 8 minus 2 is 6 over 2, and they give me 3. And this is true. Why? If we go back to the linear function, as I said before, this is the slope of the function. This is the y-intercept of the function. So again, this is the slope here, and we get the same slope. And this is the y-intercept. And this is true because if we look at the graph, this is the y-intercept across the two. Any question? Okay, so now let's go to the slope and rate of change. Slope and rate of change. So let me give you the definition for the slope and the rate of change. What's the relation between the rate of change and slope for linear function? So like I said in the previous section, this section, not this one, the average rate of change. After we did this example for the linear function, I said the slope and the linear function and the average rate of change are constant, the same as the slope. So the slope and the rate of change of the linear function are the same exactly. Okay. So for the linear function, the rate of change and the slope are exactly the same. So for the linear function, suppose my linear function f of x equal ax plus b, the slope of the graph of the function f and the rate of change of the function f are both equal a, this a. So the slope is equal a. We use different color. Slope the graph of the function f is equal a, the rate of change of f is equal a, this a. Okay, so I can say here a is equal slope of graph f, and this is equal again the rate of change of f. Okay. Example. Let f of x equal 4.5 x plus no, I don't like fraction, 4x plus 2. The question is sketch a graph of the function f. Second part, what is the slope of the graph number 3, what is the average rate of change. Who will do the first one? Sketch a graph. Just tell me what's the y-intercept, what is the slope?
The y-intercept is 2 and the slope
Is
is 4.
2. Yes, okay. So for the first one, f of x equal 4x plus 2. This is the y-intercept. And I know this is a graph look like a line. And here is the slope. And the slope is positive. This means the slope is positive, the graph look like this. So again, the slope is positive, so the graph will be look like this. But if the slope is negative, the graph will be look like this, as we learned before. Now here the slope is 4 and the y-intercept is 2. So the y-intercept is 2, so the point it's gonna be like here. This is 1, this is 2. And the graph will be something like that. Now, to find the x-intercept, make this equation equal 0. Mean, like we learned before, 0 equal 4x plus 2. Now you solve this equation, I get 4x equal minus 2. I move this one to this side. Divided by 4 for both sides, x equal minus 2 over 4 is 1/2. So this point here is minus 1/2. And this point here is 2. And the slope for this line is 4. Slope equal 4. So this is the function f of x equal 4x plus 2. Any question? Any question for the first part? Okay, for the second part, what is the slope of the graph? We already said about the slope. The slope is A, is 4. For second one, I know f of x equal 4x plus 2. It's like equivalent to something like ax plus b. So this is the slope. So the slope equal 4. Now for part number 3. What is the average rate of change for f of x? Like I said here, a equal the slope of the graph and equal the rate of change of for the function. So the average rate of change equal the slope. So this is mean the average rate of change of change is 4. Any question? Okay. Can you hear me?
Yep.
Yeah.
Okay.